Dear students, in the chapter of Design of Riveted Joints, today's lecture is Strength of a Riveted Joint and Efficiency of the Joint. I, Dr. Balraj Singh Brad from Yadavindra College of Engineering, Talwandi Sabo, India, am presenting the lecture. Let us find the strength of a double riveted butt joint. We will be explaining the procedure for strength of riveted joint with the help of a double riveted butt joint with the two unequal plates. We have two plates, 1 and 2, subjected to a tensile load, making a butt joint. Lower butt strap is larger in size, upper butt strap is smaller in size. So, inner rows of rivets pass through three plates, but outer rows of rivets are passing through two rows. So let us find out the strength of this joint to failure by different modes. In the design of riveted joints, there are certain assumptions which are made. Let us discuss those. First, the load is distributed among the rivets according to the shear area. The rivet having lesser area is sustaining lesser load. There is no bending stress in the rivets. The tensile stress is equally distributed over the section or the metal between the rivets. In a rivet subjected to double shear, the shear is equally distributed between the two areas in shear. The holes into which the rivets are driven do not weaken the member if it is in compression. After driving, the rivets completely fill the holes. When we consider these first 6 assumptions, what we find is actual stresses are more than the assumed stresses or theoretically calculated stresses. But when we consider 7th assumption, that is, friction between the adjacent surfaces does not affect the strength of the joint. Basically, why the friction between the adjacent surfaces is there? Because when we make the joint, suppose the rivet is hot riveted. When rivet cools down, rivet tries to shrink, and in the process rivet holds the plates tightly, and because of the tight holding of the plates and rivet heads, there is a friction between the plates and the plate and rivet heads. So basically, if we consider seventh assumption, we are introducing a factor of safety in the design of riveted joints. Overall, experience tells if we make these assumptions, the results obtained are very much reliable. Now moving on to the problem. Let us first discuss failure by tearing at the outer rows of rivets. To the two plates, a tensile load PT, which is denoted per unit pitch, was applied, and what we find that, say, the left plate teared at the outer rows. So since we have to define the tearing resistance per unit pitch, we find that the area of the plate which is under tear is shown by red highlight. It is shown as red highlight. Let me make the laser pointer here. And when we want to calculate this, so we know the distance between the two rivets is pitch. So pitch minus half dia on this side, half dia on this side. So P minus D is the width. P minus D is the width. T is the thickness of the plate. So red shaded area where the tear per unit pitch is taking place is P minus D into T, as we already know. So tearing resistance offered, or strength in tearing, which is the maximum load per unit pitch which can be sustained by the riveted joint to the failure by tearing at the outer rows is P minus D into T, tearing area per unit pitch, into the allowable tensile strength. We have already done, so we applied this to the present problem to explain this. Next, failure by shearing of one rivet in double shear and the other rivet, or one rivet in single shear. What we note down is, to the plates we applied, say that the shearing resistance per unit pitch is PS and the pitch is P. We find that the suppose under the load left plate moved to the this position and the rivets in the inner row and outer rows got sheared. What we observe that the rivets on the inner row, or the gauge line, are passing through the three plates, so they are under double shear, one area above and one at the bottom, while the rivets in the outer row are passing through the plate and the lower butt strap, so they are under single shear at the bottom area here and here. Now, so what is there is half rivet here, half rivet here per unit pitch, means total one rivet is in single shear. And this one rivet, complete rivet, is in double shear. And now the total load or resistance which the joint will offer to the failure by shearing of rivets is PS. Now first let us take a single rivet whose cross sectional area is pi by 4 d square. K means double shear. Theoretically it is 2, but we can take it to be from 1.75 to 1.875. For boilers, usually according to Indian boiler regulations, we take the value to be 1. K value according to IBR, Indian boiler regulation is 1.875. But for the present problem, we will be taking the theoretical value 2. Tau is the allowable shear stress of the material of the rivet. Now, other rivet which are at the outer rows, half rivet and half rivet, making a complete rivet per unit pitch, area single shear into the allowable tear strength. So we will find out the resistance offered by the joint to failure by shearing of the rivets. Next, the joint need not tear at outer rows. Sometimes the joint may tear at the inner rows too. So failure by tearing at the inner row of rivets and shearing of one of the outer row rivets. When it takes place, what we have observed is the rivet along the inner rivet line, say this line, it got teared, a plate got teared. But for the rivet a plate to move from this position to this position, the rivets in the outer row, they got sheared. Now, what we have observed is, to if we applied a certain load, say PT dash, to tear at inner rows, we need to shear half rivet and half rivet, complete rivet per unit pitch at the outer rows, and we have to tear the plate this much area, which is basically P minus D into a shaded portion, this and this. So P minus D into T is the thickness of the plates. So the resistance offered by the joint to the tearing at inner row and shearing of the rivet in the outer row is the tensile load required to tear the plate. It is area of the plate under tear per unit pitch into allowable tensile strength, pi by 4d square, area of the rivet under single shear in the outer row to the allowable shear stress. Next is the failure by crushing in front of two rivets. Why two rivets? Per unit pitch, we know for a pitch, half rivet here, half rivet here means complete one rivet in the outer row and one rivet in the inner row. Two rivets are under compression. So we want to find out the crushing resistance offered by the rivet to failure by crushing of the two rivets per unit pitch. So what we do, we find this crushing resistance. 2 is the Z number of rivets under crushing. dt is D is the rivet hole dia, T is thickness. This is the projected area of the rivet under crushing. Sigma C is the allowable crushing strength. So we multiply as discussed in the previous lectures, and we are able to find out resistance offered to failure by crushing of the rivets. Next, failure by crushing of one rivet and shearing of one rivet. What we observe is, suppose we apply the load, the problem can be that the inner rivet per unit pitch, full rivet, may get crushed, and during the crushing, the half this and half this, complete one rivet per unit pitch in the outer row may get sheared at the area shown as the red highlighted portion. So red highlight in the outer row shows the shearing of a single rivet. Red in the inner row shows the crushing of the rivet. So the resistance offered by the rivet to shearing and tearing and crushing of a single rivet is, for the inner row rivet which is getting crushed, dt is the projected area, sigma c multiplied by sigma c is the allowable crushing strength, pi by 4d square is the area under shear of single rivet which is in the outer row to multiplied by the allowable shear strength of the material. This gives the maximum load per unit pitch which the riveted joint may take to prevent the failure by crushing of one rivet and shearing of. Now, once we have calculated the resistance offered to different type of failures, as we already discussed, we can find out the efficiency of riveted joint. We already discussed shearing efficiency is shearing resistance of rivets to the tearing resistance of solid plate. We already discussed shearing resistance is pi by 4d square, area under shear of a single rivet, multiplied by shear strength, K factor for double shear, Z is the number of rivets under shear. Sigma TPT is the strength of solid plate. Similarly, tearing efficiency is tear resistance of riveted plates to tearing resistance of solid plate. Eta T is P minus dt is the area of the plate per unit pitch which is getting teared multiplied by available tensile strength. Sigma TPT is the strength of the solid plate. Eta C efficiency in crushing is crushing resistance of rivet or the plate depending upon if the rivet crushing strength is less then it is for rivets, otherwise for the plate. To the tearing resistance of solid plate. dt is the projected area of a single rivet under crushing. Z is the number of rivets multiplied by allowable crushing strength sigma c to the solid plate. Now the joint efficiency is the lowest of the three efficiencies which we will be calculating. Next, let us solve a design problem for this type of a double riveted butt joint with two unequal cover plates which is made between 8 plates. Means thickness of the plates is both plates is 8 Rivet hole diameter is given to be 15 and pitch of the rivets is 60 The joint is zigzag as shown in the figure. The allowable stresses in tensile is 35 megapascal, in shear is 29 megapascal, in crushing is 52.5 megapascal. Usually crushing strength is 1.5 times sigma t. Now given is T 8 rivet hole dia 15 pitch 60 allowable crushing strength, it is tensile strength 35 megapascal, shear strength 29 megapascal and crushing strength of 52.5 megapascal. Now we have the relations to find resistance to tearing of the plate at the outer rows. Relation is there. We put the value of P 60, D 15, thickness of plates 8, allowable tensile strength 35, and when we solve we find that the joint is able to take 12,600 Newton load per unit pitch. All the loads which we are calculating are per unit pitch to prevent the failure of this joint by tearing at the outer rows. Then is resistance to shearing of rivets PS. We have the relation K theoretical factor for double shear 2 pi by 4d square. D is the rivet hole diameter is 15, area 29 is the allowable tensile strength. Again we put and we saw that if the riveted joint is able to take 15,374.17 Newton load per unit pitch to prevent the failure by shearing of the rivets. Next, resistance to tearing at the inner rows of rivets and shearing of one out of the outer row rivets. Relation we calculated, P value is 60, D rivet hole dia is 15, thickness is 8, allowable tensile strength is 35, and shear strength is 29. We solve. Let this is denoted as PT dash is 17,724.72 Newton again per unit pitch. Then resistance to crushing of the rivets. Two rivets are under shear per unit pitch. D is rivet hold is 15, thickness of plates is 8, and allowable crushing strength is sigma C. It comes out to be PC 12,600 Newton, which is for the present case PT tensile strength to the tearing at outer rows and strength to the crushing of rivets is same. Next, resistance to crushing of one rivet and shearing of one rivet. We put in the relation D 15, rivet hold dia thickness 8, sigma C is 52.5 and tau 29. We calculate this to be PS dash 11,424.72 Newton. Now tearing resistance of solid plate. It is PT area of the plate under tear per unit pitch, which is simply pitch into thickness of plate sigma T allowable. This is pitch 60, thickness 8, sigma T, P solid comes to be 16,800 Newton. Now the joint efficiency. We calculate eta T tearing efficiency to the tearing resistance by solid. It comes out to be 76.19%. Shearing efficiency, shearing resistance to the solid plate resistance. We put the values and it comes out to be 91.51% for the given problem. Eta T dash, which is the efficiency to the failure by tearing at inner row and shearing of one rivet in the outer row. It is PT dash by solid. It is 105.5%. Eta C, crushing efficiency, crushing resistance to the solid resistance is 76.19%, and for the present problem it is equal to eta T and is given. Now eta S dash, it is the lowest efficiency for the present case. It is PS dash. PS dash is resistance to crushing of one rivet in the inner row and shearing of one rivet in the outer row per unit pitch to the resistance offered by solid plate to tearing. So it comes out to be 68%. So this is the lowest efficiency. So the lowest efficiency is termed as the joint efficiency. So we have calculated that this joint has a tendency to fail by crushing in front of one rivet and shearing of one rivet. And if we want to increase this, we have to increase the rivet hold dia to slightly increase the efficiency of the joint. In this way, we can find out the strength of different riveted joints, their efficiencies, and hence the joint efficiency, and check whether the joint will sustain a load. Thanks, dear students.